So this is the last distribution we have seen yesterday, geometric distribution, where it is used for queuing theory, or it is used for many purposes. Like we have seen real life kind of example. If you are interviewing, say, 100 people for some post, and then you have to select that, or for that position you have to select a person who is more appropriate. Then if the position is much more higher, then in that case definitely they keep on taking the interviews, and they may get the failure for, say, 4 or 5 sessions, and after that they get the person who is proper for that particular post. So these are all the examples of the geometric distribution. Now we will take the next one as exponential distribution. This is having many applications because it goes, as the name is given, it goes exponentially. So this is for the continuous random variable earlier, which we have seen it, and that is for our discrete random variable. Now for a random variable, kind of continuous type of random variable, we have seen one distribution that is called as normal distribution. Now here there is one more distribution, and that distribution is for the continuous random variable is exponential distribution. So definition for the exponential distribution is, it is a continuous random variable. We are taking that random variable, say capital X, and taking non-negative values. Taking non-negative values is said to follow the exponential distribution with a mean theta. The mean is what in this case? Theta. If it's probability density function, they see, in case of continuous random variable, we write it as a probability density function. And in case of a discrete random variable, we write it down that as probability mass function, that is PMF. Okay, so that's a difference. So here, the probability density function is given by 1 upon theta e raised to minus x by theta for theta positive, because unless and until we take x positive, it won't converge, correct? Because if you take that x value as negative value, then in that case it will keep on increasing and it will go to infinity. But here you can see that that goes to 0, and when x tends to infinity, correct? So here we have f of x as 1 by theta e raised to minus x by theta, and theta is strictly greater than 0, even x is greater than equal to 0. Okay, so at infinity, when theta is infinity, again we don't have any problem, because the entire thing goes to 0. Entire thing goes to 0. So you can see that the function is defined for x positive and theta is greater than 0. F of x, the formula for the exponential distribution is what? 1 upon theta e raised to minus x by theta. And now for exponential distribution, the way we are using for geometric distribution, capital G of P, okay, where P is the probability of success. Similarly, here the notation is what? Capital EXP, okay, capital E and XP is small, so exponential of theta, okay. So this way we represent this. So now the first thing is we have to verify whether this function is a probability density function or not. See, we have seen such kind of examples earlier for checking whether it is a probability density function. The meaning of this is what? That is, the integration minus infinity to infinity y dx must be equal to 1. Okay, so here y, in place of y, what we have fx dx, correct? So obviously we are going to check whether the function is positive or not. So once we say that the given function is positive, what we are going to do is, we have this definition that minus infinity to infinity y dx is equal to 1. So let us take the left hand side of this. Okay, what is the left hand side? Minus infinity to infinity. What we have here, it is 1 upon theta e raised to minus x by theta dx, correct? And we'll integrate this. So what we get this as, so this is 1 over theta, we can keep it outside. And what is there? It is e raised to minus x by theta divided by, divided by, we get minus 1 by theta, correct? From minus infinity to infinity. But then we know that the value is defined only for x positive, elsewhere it is 0. So this limit here, when you take this, it will start from 0 to infinity because the function is defined from 0 to infinity, correct? So I'll get this as 0 to infinity, and then you just substitute this when I just take this theta outside. So it is minus theta by theta, and we have to just put e raised to minus x by theta from 0 to infinity. So let us substitute the value. So here it is minus of, when it is infinity, it is 0. And when we put it 0, it is 1. So you can see that the answer is 1. So that is our right hand side. And hence this is the probability distribution, a density function. Okay. So hence it's probability density function. So whatever the function is defined, earlier function is defined, it becomes a probability density function. It becomes a probability density function. So this way we have seen such kind of things earlier. Okay. We have seen such kind of thing earlier. Whenever it is a discrete random variable, there we show that a summation of that distribution, probability distribution function is 1. Correct. And in case of density function, it's a continuous random variable where we know that the integral minus infinity to infinity of y dx is 1. So we have checked all the things. Okay. So this becomes your probability density function. Okay. The function which is defined here, it becomes probability density function. So now let us move ahead. So we have defined a definition of exponential distribution. We have defined PDF for that. And now we have checked whether it is PDF or not. Correct? So how the curve will look like? How the curve will look like? You can see the curve. See, as x goes to infinity, it will converges to 0. So you can see that when they substituted theta as 1, the curve is look like this. When theta is equal to half, okay, when theta is equal to half, we are getting that curve is nothing but it looks like this, correct? So here these are the curves given. So this is for theta equal to half. So you put theta equal to some other value and check, okay, check it, and that way we'll get the different results for this, correct? So you can see that in this diagram that this is positively skewed curve. Yes. So you can see that the elongation is there on the right hand side. Correct. So that means it is positively skewed. We have seen the skewness. Correct. So it is positively skewed curve. So and the mode of the distribution is 0. Correct. Because here the value is going to be maximum value which is occurred. So that maximum frequency, you can see that it occurs at 0. So therefore the mode is going to be 0. And when this distribution is used, the value of the mode cannot be taken as average. Okay. So it is nothing but the value of what we can say. It's a value of maximum number of values which are occurred at 0, like this. Now, if theta is equal to 1, if theta equal to 1, this distribution is called as standard exponential distribution. So what is our actually function? The function we are writing it as 1 by theta e raised to minus x by theta for x is positive and theta x is positive and theta is also greater than 0. Otherwise, it is 0. Correct? This is our formula. Now here we are putting theta as 1. Here we substitute theta as 1. So here theta is 1. So what I get f of x is like this. Correct? So here when you substitute theta as 1, 1 by 1, e raised to minus x. So we are getting this function as fx is equal to e to the power minus x, and otherwise it is 0. So this is called as standard exponential function. This is called as standard exponential function for theta equal to 1. Theta equal to 1. Now, what are the mean and variances here? So, for exponential distribution, the mean is theta. Okay, mean is theta. Variance is theta square. So, standard deviation is theta, of course. Okay, so you can see that for the exponential distribution, the standard deviation and mean, they are same. You can see that both of them are theta. So therefore, the standard deviation and mean, these two things are same. These two things are same. Now let us move ahead. So now next thing is distribution function of exponential distribution, correct? So what is a distribution function here? So we know that how you define it. This is defined for the probability. We calculate actually that is nothing but the probability for x is less than equal to x, correct? X is less than equal to x means what? It will range in between 0 to x. It will range in between 0 to x, and we are interested in calculating that probability function. So how you get that? So you can see here that fx is what? Fx is defined as probability for x is less than equal to x. Means what? Here, what is the value of x? Small x. We know that x is greater than equal to 0, correct? So this value, it will take it from x, okay, x. So I just take it that this x, okay, till x, till x. So this is your probability. So therefore, what is this density function? We know that it is integral 0 to x of f of t dt, and they are just writing it as in place of x, they are writing in terms of t. What is our fx actually? We have defined fx as 1 by theta e raised to minus x by theta. So what will be f of t? Just replace this x by t, correct? So we get this function, we get this function, because here the limit is also x. So to avoid the confusion, they are taking it in terms of some variable t. Okay. Now you integrate this. Once you integrate, we get the value as this, correct, after substitution. So it is what? 1 minus e raised to minus x by theta. Okay. It becomes what? 1 minus e raised to minus x by theta. So probability for 0 to x, 0 to x is nothing but 1 minus e raised to minus x by theta. So here the note is given. When x is lifetime of a component, then probability for x is greater than x is taken as reliability function or survival function. So you can, as I said, in many of the reliability problems, okay, maybe it is computer network, in networking problem and all, they are using this exponential distribution. Okay, they're using it exponential distribution. So it has vast applications among all of them, correct? Like normal distribution, we have the maximum applications for this exponential distribution function. So what is the probability for x greater than x? It is 1 minus. So you can see that what is the probability for x greater than x? Means it is a complement, correct? This is capital X. So it is what? It's a complement function. So 1 minus probability for x is less than equal to x. And we know that it is 1 minus, just now we calculated that it is 1 minus e raised to minus x by theta, correct? So what I get this as? So 1 minus 1 plus e raised to minus x by theta, and that gets cancelled. So we get e raised to minus x by theta. So you can see that probability for x greater than x, that is x to infinity. So what is the meaning of this actually? This is nothing but integral x to infinity of fx dx, correct? It is like this. So that is nothing but your function e raised to minus x by theta. Okay. So this just you have to remember. Now moving ahead. So here it has a lack of memory property. There are some properties. One of them is called as lack of memory property. So this is an important property where the exponential distribution possesses. So for say probability, the statement is given when x is the continuous random variable possesses exponential distribution. This way we read it. If x tends to exponential of theta, how to read it? So when the continuous random variable x possesses the exponential distribution, then probability for x is greater than equal to s plus t by x is greater than, so that is x is greater than equal to s plus t, given it is nothing but x greater than equal to s. Actually it has to be given, so that given line has to be bigger one. Okay, so it is for the next time. We are saying that it is having some time property. Okay, so s plus t given x is greater than equal to s is equal to probability for x is greater than equal to t. And they have proved that. Okay, they have proved that. Now we don't require the proof, but then you need to remember this property, and this is called as the lack of memory property. Lack of memory property, where we are taking this given. Okay, this is like, this is your given. Okay, so it looks like this, a given b, like that. Okay, so we have here x greater than equal to s plus t given like this. Okay, x greater than equal to s. And what is this? This is nothing but the probability for x greater than equal to t. X is greater than equal to t, like this. Okay, so this way please remember this. So this inequality here, this inequality here in the star can be written in this form also. So they have given the property, one more note here, that the probability for x is greater than equal to s plus t is nothing but, since they are independent, so we can have the multiplication of this two. Okay, so it's a kind of multiplication. Okay, so it is like this. So since it is given properties there, and these are the independent events, so we'll get this as probability for x is, this way also you can remember, probability for x is greater than equal to s plus t is probability for x greater than equal to s into probability for x greater than equal to t. Okay, x greater than equal to t. So it's a quite interesting one, interesting property here. So this is very easy to remember. Now, moving ahead. So the converse of the above statement is also true, that if x is a continuous random variable taking non-negative values such that the third, that multiplication thing is hold good, then the x is a exponential distribution, okay, in terms of theta. So this is the characteristic property of the exponential distribution. It's very important, and it's a characteristic property of the given thing. So how you can write it down, the another way of writing this, that it can be written as the probability for x is greater than equal to s plus t given probability for, that is x greater than s, is nothing but for x greater than equal to t, where what is x, such that x is greater than 0. So here x is a lifetime of an electronic component. Okay, so here actually it is, as I said, in reliability and all we are using this. So those components we are considering it as the time component. Okay, and many a times, like if you go ahead for even for the server connectivity and all. Okay, so to find it out, to rectify the error, we are using this distribution. Okay, so here, how to solve the problems based on this. Okay, how to solve the problems based on this. So what is given, suppose that the lifetime of a certain make of random of a TV tube. Okay, it's a TV actually. So of a TV tube, so this is TV tube, of TV tube is exponentially distributed. So see, everything is mentioned here. So we don't have to worry about which distribution we have to apply here. Okay, so exponential distributed with a mean life, with a mean life of 1600 hours. What is the probability that the tube will work up to 2400 hours? The tube will survive after 1000 hours. Correct. So here you can see that we can take the values, higher values, and then we can look for that. Okay, that is not possible in other cases. Okay, so here I can go up till infinity for any value, and we can find it out the probabilities. So what is the given thing that we have to take first of all the formula for exponential distribution. So x is what? X is the number of hours of the TV tube works, correct? Now given x as exponential distribution theta, where theta is what? Mean life is 1600 hours. So theta is a mean. Okay, so always remember that here theta is nothing but the mean value or the average, it is given to you. So here theta is what? Theta is 1600 hours because it is given that mean life is of 1600 hours, correct? So that is 1600. Now what is the probability for x less than equal to x? Because I have to find it out, the tube will work up to 2400 hours, correct? The tube will work for up to 2400 hours, means I have to find it out this. Correct. So probability for x is less than equal to 2400. And just now we have seen the formula when we have seen the distribution function. The probability for x is less than equal to x is nothing but 1 minus e raised to minus x by theta. Correct. So that we have seen it for x greater than 0 and theta greater than 0. So here just you substitute in this formula, just you substitute the values. So what is x? X is 2400. What is theta? 1600. Solve this. So we get the answer. So this is the answer. Correct. And as I said, you just see the answer is given up to 4 to 5 decimal places. Okay. So check the answer up to that decimal place. Yes. Now the next thing is given, the tube will survive after 1000 hours. Means what? Probability for x greater than 1000. So just now we have seen that the probability by using this complement, probability for x greater than x is what? It is 1 minus probability for x is less than equal to x. And we know that it is 1 minus, as we have seen, 1 minus e raised to minus x by theta. And that answer is e raised to minus x by theta. So we are using directly this formula. So here see, they are using that formula. So e raised to minus x by theta. So substitute x as well as theta. What is x here? 1000. And theta in this case is the average, which is 1600 given. So we get the answer, required answer. Okay, all of you have understood this. See, the problems are very easy and it will be given like for Poisson distribution, it is given as they are using the Poisson distribution. Okay, for normal distribution, they will be given that it is normally distributed. For geometric also, you can identify that because the earlier are the failures and for only one value, they will ask you. Okay, like the fifth person which we have seen interviewed and it is getting selected. So for that, identify that particular thing and earlier all are failures. Then in that case, you are using geometric. Okay. And for binomial, of course, you have to see that the probability is not so small, that is, it is 0 point something. And the value of n is not large. So n will be 10, 20 like that. So it is easy to find it out. Okay. And it has exactly two outputs. Correct. Now, we'll take the next example. So another example is given that the lifetime in hours of certain electric component follows exponential distribution with a distribution function. The function is provided. Okay, it is what? 1 minus e raised to minus 0.004x. Correct, for x positive. So what is the probability? What is the probability that the component will survive 200 hours? The probability that it will fail during 250 to 350 hours, and expected lifetime of the component. Okay. So now what we'll do is we'll take, first of all, you have to identify the random variable. That is very important thing here. Okay. So you need to identify first of all the random variable. So what is x? X in this case is the lifetime in hours of electric component. Okay. And it is already mentioned in the example itself that it is exponential distributed. Correct. So that component, electric component, follows exponential distribution. Exponential distribution. So what we do is we have the formula. They have given the density function to us. What is that density function? 1 minus e raised to minus 0.004x. But what we know, We know the density function, probability density function for the exponential distribution, and that is what 1 minus e raised to minus x by theta. Correct. Now here, when you compare it with a given thing, you'll find it out that theta is what? Theta in this case is what? It is minus 1 by theta is nothing but, oh sorry, 1 by theta is nothing but 0.004. Correct? 1 by theta is what? 0.004, and therefore we get the value of, in this case, so here 1 by theta is sorry, it is 0.004. Correct? So what is the value of theta? It is 1 upon 0.004, and that they are getting it as 250 hours. Now, once you get the value of theta, theta is nothing but the mean, correct? So this is your average. It's a mean, correct? So once you get the value of theta, everything becomes very easy. So what we have to do is we have to just find it out here. The probability for x greater than 200, because the probability that the component will survive 200 hours, correct? So it is what? For greater than 200, the value is e raised to minus 200 by 250, which is e raised to minus 0.8, and that value is 0.449329. Okay, so this way we get the first answer. Now for second answer, we have to find it out that it falls in 250 to 350 hours. So probability will have the range 250 to 350, correct? So you can see that the probability will have the range from 250 to 350 here. So that is probability for x is greater than 250 minus probability for x is greater than 350, correct? Are you all getting this? Because see, it's like we have the range between 250 to 350, correct? 250 to 350. Now we have the formula for probability for x greater than x. Correct. X greater than x. So what we do is we will take the probability for, say 250 to infinity. Correct. So 250 to infinity. So that is probability for x is greater than 250. So this is 250 to infinity. And secondly, we have the probability for 350 to infinity. So we have the probability for 350 to infinity, that is greater than 350. Now what I wanted to find it out. I want to find it out this probability. Okay. So what we do, we just have this value is greater, no? So you just subtract, correct? And that the same thing they have done it here. All of you are getting? So this way you can solve this because we have a formula for this one, correct? So this is your probability for x greater than 250 minus probability for x is greater than 350. So you substitute the values and get the answer, correct? And the last thing is what is the expected value? So that is nothing but theta. We know that mean, variance, and they can ask you the value for mean. Okay, so what is the mean? We have seen that mean is theta, so that is 250 hours. What is the variance if they ask? So variance in exponential distribution. So see, the questions on this is very easy, correct? So variance is nothing but theta is equal to, you can have theta square, so it is 250 r square, correct? Then what is the standard deviation? Standard deviation is same as this mean, correct? And that is your expected value actually. That's your expected value. So this way you can solve the questions here based on this, and it's quite easy to solve the questions. Okay, it's very easy actually. Now let us move ahead. Okay, so here there are some questions. So the first question, so choose the correct option. Okay. So a random variable x has exponential distribution with mean 6. With mean 6. Now what you have to do is you have to find it out the probability for x greater than 9. X greater than 9 given x greater than 3. So it is like we have seen no just now probability for x greater than s plus t given probability for uh, x greater than s. Correct? So mean is 6. Mean is 6. So what is that? What should be the answer? So please take the screenshot of this so that we can go ahead with the solution. So now what we are going to do here, that we have seen the formula, and that formula is nothing but for the lack of memory, correct? That property is given. So what we have here, we have seen that probability for x greater than 9, given that probability for x greater than s, one can use the formula for probability for x is greater than equal to s into probability for x greater than equal to 3. The mean is 6. Mean is 6. So here actually t is nothing but the value of theta and s is a parameter. So the value of theta is given as 6. So we have this. So here you can just take theta is nothing but your t. So probability for x greater than this is 6 plus 3 given probability for x greater than 3. It is like this, correct? It's like this. So what we have the formula for this is nothing but the probability for x is greater than equal to t. So t is nothing but here 6. So what we get this as? We have the formula for probability for x is greater than equal to t is e raised to minus t by theta. Correct. And here you have this as e raised to minus 6 by 6. So this will get cancelled and we get the answer as E inverse. So the answer is D. Okay. The answer is D. So this is your lack of memory property. By using that, we can solve this question. We can solve this question. What we have is, we have here fx is a PDF, probability density function. And fxx is representing the distribution function. Okay. Exponential variate x with mean is 4. Now, what is PDF and fxx? We know that the relationship fxx is distribution function, and how you write that distribution function? It is nothing but 1 minus e raised to minus x by theta, correct? This is a distribution function. And how you write it down fx as PDF? It is e raised to minus x by theta for x is greater than 0 and theta is also greater than 0, correct? And 0 elsewhere. Same thing is here, x greater than 0 and theta greater than 0, correct? Now, what is the mean here? Theta is given. Theta is 4. That is given to us. We have to find it out the value of this. Value of this. So what is that? So substitute it here. Substitute the term. So, oh sorry, here it is 1 by theta, no? I'm so sorry. So what is your fxx upon this? So I just solve it here. So what is fx upon 1 minus fxx? So fx is what? It is 1 by 4 e raised to minus x by 4 whole divided by 1 minus fxx is what? 1 minus e raised to minus x by 4. Correct? So this will be equal to 1 by 4 e raised to minus x by 4 whole divided by this 1 gets cancelled, correct? And we get this as e raised to minus x by 4. So now this also gets cancelled. And what is the answer? 1 by 4. So the answer is B. Okay. So you need to understand the question. So here fx is a probability density function and capital Fxx is a distribution function, and we have seen distribution function also, the formula, as well as we have seen the formula for probability density function also. Correct? So please take it down properly so that you'll understand how to solve such problems. Correct? Now, let me clear this. Now we'll go ahead. We'll see this problem, problem number 14. A random variable x has exponential distribution with mean 4. Hence, variance of the distribution is, what is mean? Mean means it is theta, correct? Mean means it's a value of theta. Theta is 4. What is the variance? Variance is theta square. So that will be 16. Correct? So the answer is what? 16. The next question is the range of an exponential variate. What is the range where it gets mapped? It is mapping to 0 to infinity. Correct? The range of exponential variate is 0 to infinity. Now, if a random variable x has exponential distribution with mean theta, then its distribution function. What is the distribution function? Just now we have seen it is 1 minus e raised to minus x by theta. Correct? That is our distribution function. That is fxx. Okay. Now the 17th one. A random variable x has exponential distribution with mean 1. Then probability for x greater than 2. Just now we have seen the probability for x greater than x is what? E raised to minus x by theta. Now here it is probability for x greater than 2. What is this? It is e raised to minus 2 by theta. But what is mean? But mean is 1. Mean is 1. That is theta is 1. So substitute it here. So this becomes what? E raised to minus 2. So the answer is what? P. Okay. So this way, see, these are all the questions are nothing but a memory game here. You need to remember proper formulas. Once you remember that, all variety of answers are there. See, for distribution function also it is given 1 minus e raised to minus 2. So it is a kind of googly, correct? So you need to understand such questions and then you have to follow it accordingly. All of you are getting this? So this are the questions. Some of them can be true or false kind of statements where you need to understand whether it is true or false. Okay, so for that you need to remember the formulas as well as the statements, correct, properly. That will help you out. So we'll have such kind of things in our all the test series so that it will build your confidence and that will definitely revise the terms, correct? Okay, so with this, I end this lecture and I take attendance also. Just wait.